All right, let's talk about Python. If you've spent any time at all coding, you know it's all about handling data, right? You've got your numbers, your text, your lists, but what happens when they just refuse to cooperate? Well, today, we're going to take one of the most common, most frustrating Python errors and flip it on its head, turning it into a tool that actually gives you more power.
So let's start with a feeling I'm sure you know all too well. You write your code, it looks perfect, you hit run, and bam! A big red error message. More often than not, it's because you and Python had a little disagreement about the kind of data you were trying to mix together.
Ah, yes, this old chestnut, the type error. You've probably seen this a million times. What Python is really saying here is, whoa, hold on. You've given me a number and a piece of text and you want me to add them? I have no idea what that even means. You need to be more specific. It's a classic roadblock, and honestly, it trips everyone up at first.
And that probably makes you wonder, come on, Python, why can't you just figure it out? But here's the thing. This isn't a bug, it's actually a feature. Python is designed this way on purpose to avoid guessing games. By being strict, it forces you to be crystal clear about what you want, which saves you from those really sneaky, hard-to-find bugs later on. It all boils down to one fundamental idea, the data type.
You can think of a data type as a label that's attached to every single value in your program. That label tells Python what kind of thing it is, and, more importantly, what you can do with it. You know, you can add two numbers together, that makes sense. But trying to add the number 10 to the word apple, the rules just don't allow for that. They're different kinds of things.
But, and this is where it gets really interesting, Python isn't just strict, it's also pretty smart. In some situations, it can figure things out on its own, and it does it so quietly you might not even notice. This is our first kind of data conversion, the automatic kind.
Okay, so take a look at this. Super simple code. We've got an integer, 1, and a floating point number, 1.0. We're adding them. Now, based on that type error we just saw, you might think this is going to break, right? But what do you think Python does here?
And the answer is 2.0. It's a float. Now, the magic here isn't just that it works, it's why it works. Python looks at this and thinks, okay, if I change the float 1.0 into the integer 1, I'm going to lose that decimal information. That's risky. But if I promote the integer 1 to the float 1.0, I don't lose anything. So it chooses the safest path to avoid losing any data. Pretty clever, right?
This whole automatic process has a name. It's called implicit conversion. Think of it as Python's built-in safety net. It automatically and silently changes a data type to a more precise one, just to make sure an operation can happen without destroying any information. It's Python trying to help you out.
But that doesn't solve our original problem, does it? Adding a number to a string is still a no-go for implicit conversion. For that, we have to stop letting Python be the smart one and start giving it direct commands. This is where you, the programmer, get to take control.
So let's revisit our old nemesis, the type error. Here's the exact situation again. We've got the number 21, and we're trying to sandwich it between two strings. Python's hands are tied. It's not going to guess. It's waiting for us to tell it exactly what to do. And here is the fix. Check it out. By wrapping our total variable inside that string function, we are explicitly telling Python, hey, that number, I need you to treat it like a piece of text, just for this one operation. And boom, just like that, the error vanishes. Problem solved.
This manual approach is called explicit conversion, or as you'll often hear it, type casting. You are literally casting a value from one type into another. This is you grabbing the steering wheel from Python and saying, don't worry, I got this. I know what I'm doing.
So let's just quickly compare them side by side. Implicit is automatic. Python's in charge. Explicit is manual. You're in charge. Implicit is always safe. It's designed to avoid data loss. Explicit is all about control. But that control comes with a catch. You can now cause data loss if you're not careful. So let's talk about that risk. Let's say we have the floating point number 3.9. For whatever reason, we need it to be a whole number, an integer. So we explicitly cast it using the int function. What do you think my int is going to be? It's 3, and this is so important to remember. It's not 4. When you convert a float to an integer in Python, it doesn't round to the nearest number, it truncates. That means it just chops off everything after the decimal point, no matter what it is. That .9 is just gone forever. You took control, and you lost some data. You just have to be sure that's what you intended. Okay, so now you get the power and the pitfalls. Let's start filling up your programmer's toolkit. Python gives us a whole bunch of these built-in functions for typecasting.
and they work on everything from simple numbers to much more complex structures.
These are the big ones, the ones you're going to use all the time. Float turns a whole number into one with a decimal. Int will chop the decimal off a float or turn a string of numbers into an actual number. And string can take just about anything and give you back its text representation. These are your absolute essentials.
But this idea goes way beyond just simple numbers. You can also convert between different kinds of data collections. You can turn a changeable list into a permanent, unchangeable tuple. Or you can take a string and instantly break it up into a list of individual characters. It's an incredibly useful way to reshape data on the fly.
And here's a little pro tip for you. That same int function we used before, it has a hidden superpower. You can actually give it a second argument to tell it what number system you're converting from. So you can easily convert binary or hexadecimal strings back into the decimal numbers we use every day. How cool is that?
Phew. Okay, we've gone from a frustrating error all the way to a whole toolkit of powerful functions. So let's just zoom out for a second and bring it all home. Why is this so crucial to get right?
Look, here's the bottom line. You've got two main ways to convert data. There's the implicit way, where Python does it for you, automatically and safely. And then there's the explicit way, typecasting, where you take manual control. The secret to writing really solid, reliable code is knowing when to let Python do the work and when you need to step in and give a direct order. Mastering this isn't just a neat trick, it's a fundamental programming skill.
So I'll leave you with this to think about next time you're coding. We've seen how powerful typecasting is. It gives you total control. But you should always be asking yourself, when does that control come at a price? At what point am I sacrificing the accuracy, the integrity of my data just to make the program run? Finding that perfect balance? Well, that's what being a great programmer is all about. Thanks for joining me.